Alrighty, welcome back. It's Mr. Montana. Today we're going to be going through lesson 5.7, which is going to be Cpctc. And what that stands for is corresponding parts of congruent triangles are congruent. And we'll get a little more into that and talk about what Cpctc means. So right here we have a proof that is just going to be a simple proof talking about given that BC is going to be congruent to DA, then BC is also parallel to AD. Okay, so let's go ahead and start marking our triangle. Make sure the appropriate markings are there. So it says that side BC in D to A are congruent, which we utilize that line to go ahead and note that. And then it also says that those same sides are parallel. And all we do is we draw an arrow on those in order to make sure that we know that they're parallel. So now we have our picture appropriately labeled. Let's go ahead and look into the proof. So the proof says statement BC is congruent to DA. Well, that was given in the question, right? It says it right here. So we know that that is given. Remember the next one line is BC is parallel to AD, and that's also given. Okay. The next thing it tells us is that angle BCA is congruent to DAC. And so what this is saying is we go in order. So B to C to A, it's going to be that angle right there that I just highlighted in pink, is going to be congruent to DAC. And it's this angle right here. Okay, and that is because if we look at this, we actually really have two parallel lines cut by a transversal. And so those lines are going to end up being alternate interior angles. And we should remember alternate interior angles are congruent. And then the last thing we have is AC is congruent to CA. As y'all know, or you should know, that anytime we have a line and we just switch the letters to be in a different order, it's still the same line, right? So AC is exactly the same as CA, and what we call that is the reflexive property. We are just reflecting the letters over each other, okay? That's all we're doing. And then lastly, it's asking how did we know that triangle ABC is congruent to CDA based on the information? So let's go back to the very first step, and you'll see that we have these lines labeled out to the side for you. And so BC is congruent to DA. So ask yourself, is BC and DA side or angle? And so you should say, oh, that's a side. And so we are going to go ahead and put a side, for an S for inside. And then we're going to go to the third one that has the next line, and it says, oh, is angle BCA congruent to angle DCA? Is that talking about sides or angles? Well, it has the angle sign, right? So it has to be an angle. And then last one on question 4, it says, okay, is angle, or side AC is congruent to side CA. Is that an angle or a side? And you should be able to say, oh, well, that's a side. And so we'll go ahead and label the things we were talking about. So side are angles here and a side here. And conveniently enough, this stuff over here on this side that we just did, it does happen to put it in the correct order, but I want it to be known that that is usually not ever correct. All right, so this one is Sas Congruence Theorem. All right, so Cpctc stands for corresponding parts of congruent triangles are congruent. All right, and then the next one says Cpctc is used when it's asked to prove a corresponding part of a given triangle are congruent. All right, triangles first must be proven to be congruent before you can use Cpctc as the reason. So in other words, we have to go through the entire proof like we did just above in order to prove that the triangles are congruent. And then our very last line will usually always be Cpctc, all right? And so we get the same proof that we just did above, right? I'm not going to go through and label it again. We know that this is SAS. And so a big telltale of when we can use Cpctc is when we're talking about something with like this line symbol or if it has an angle symbol. Those are the things that tell us that, oh, we can use Cpctc as a proof. All right, looking at this next one, it says, how do you know if the last step is congruence theorem or Cpctc? So essentially, if you are using one of these, the SSS, AAS, SAS, ASA, HL, then, and it has a triangle like this, then that tells me that it's a congruence theorem. It's one of these, okay? If you are talking about something that has the line or the angle symbol, then that tells me that I can then use Cpctc, okay? So these right here tell me Cpctc, and the pinks tell me that it's gonna be SSS, or so on and so forth. All right, flipping over to the backside. All right, right here at the top of the back page, we just have some hidden information. I'm going to read them, and then I'm going to tell you what they are, all right? So blank results in two segments being congruent. If A is the midpoint of EB, then AB is congruent to AE. And so what's that saying, y'all, is we are talking about a midpoint here, all right? That's the key word right here, midpoint. And then it says that if A is a midpoint, then it's going to tell us that EB is going to be congruent to AB. All right. Now looking at the next one, this one's going to be angle bisector. And what that tells me is if AD bisects angle BAR, then angle BAD is congruent to angle RAD. So we're saying if AD, this red line right here, this bisector, bisects those angles, then BAD, which is going to be this blue angle right here, has to be congruent to RAD, which is going to be the pink angle. And that's just because when we bisect, we cut in half, right? That's just the definition of what bisect means. All right, looking at the next one. It says if two angles are vertical, then they are congruent, and this is going to be for vertical angles. And guys, you should know that vertical angles are congruent. Remember, when they form the X, the angles across from each other are going to be congruent. Then here, this one is going to be your reflexive property that we talked about earlier. And this reflexive property, guys, all that means is that I can call this AD or I can call this DA. It is the same side no matter what, right? It's going to be the same length. It's going to have exactly the same properties. And a lot of times it's going to be your third side to prove SSS. We like to throw this trick at you. This side is congruent to itself, right? Anytime we reuse it, it's always going to be the same. All right. Our next property is going to be perpendicular. And what perpendicular says is if AB is perpendicular to CD, then angle ABC and angle ABD are right angles. So in other words, it's saying if it's perpendicular, then we're forming the two right angles right here in the dead center. Okay? Oh, forgot my R. And then the last one is going to be parallel. If AB is parallel to DC, so if AB and DC are parallel, and we put the little arrow to tell us that they're parallel, then angle DAC is congruent to BCA. So this angle is congruent to this angle. And it also tells us that BAC, which is going to be this teal angle, is congruent to DCA, that teal angle. Alternate interior angles are congruent, all right? And that's what that's saying right there. All right, so let's look at this first proof. So let's go ahead and start listing out the stuff that we know. Luckily, we're given a word bank to the side that will help us fill in this proof. So the first thing it says in our statements is that TV is congruent to WV, and we can see clearly that that statement comes from our given. That's why we have given in that blank. The next statement we have is that angle T is congruent to angle W. And again, y'all, that is in the given line, so we can go ahead and put given and mark it out of our word box. All right, so let's stop there. Let's think about it. That first statement, side TV is congruent to side WV. Well, that's a side. The next one says angle T is congruent to angle W. Well, that's going to be an angle. All right, now we have to come up with our next statement, all right? And how I like y'all to do this, I just don't want y'all to use that last statement already. So highlight this last statement, circle it, draw stars around it, whatever, circle it, and you're going to draw it to the last line. Remember, that statement always has to go on that last line. So we know we are coming up with an entirely different statement right here, right? All right, so we now have our side here. We now have our angle here, right? I don't know why I wrote them twice. My bad. Right? And then we have to think about what else we'll know. And so looking at the area above where it says the properties, which one does that look like? You should be able to identify that that looks like vertical angles. So in other words, we have another angle here, and these angles are going to be congruent. So you have to be able to form that statement, and it's going to be angle TVU is congruent to angle WVX. Rewrite that. That was terrible. WVX. And that is by vertical angles. All right. And then the fourth one, we have to ask ourselves, can we use Cpctc? And the answer is no, because we have a triangle here, right? Because it has a triangle there, we can't use Cpctc. So then we have to think about, okay, well, that step 3 that we just did, was that talking about an angle or a side? Well, it was talking about an angle. We don't have something called SAA. But if we look up here at our picture, if we start at A, then would go to S, and then we'd go to A. So that tells us right there that our property is ASA. All right. Now we're going to go down here to question 2, and let's finish question 2 really quick. Again, it has a lot of information, and it has the word bank over here. So let's go ahead and look at our first line of our statement. It tells us this, it tells us this, and it tells us this, right? So on all those statements, we're going to go through and find them. So the first one, side RT is congruent to side UV. That is given. And again, guys, that's talking about a side, so let's go and write this S. And let's make sure it's marked on our picture. So RT is congruent to UV. Good. Solid. Then we're going to look at the next one. It says RS is congruent to UR. That is also given. And that is also a side. And so we make sure our picture is labeled. We're labeled. And then now it says that angle T and angle V are right angles. That is also a given. And so now we can mark out our first 3 answers out of our word bank. We've used all 3 of our givens, so we're done with that. And then now it says that angle T is congruent to angle V. Well, we know that's true because they're both right angles. That is not given, but I just said they're right angles. Therefore, that is the right angle theorem. And so we'll go and mark that out of our word box. Now let's see the next. Now we need to talk about, is that talking about angles or sides? You should be able to tell me that's talking about angles. And then now we're going to talk about, it says triangle TUV is congruent to triangle WXV. And so we have the letters ASS. And so we know, and you should remember this, I know your teachers told you already, that if it spells a bad word, it's not right. We can't use that. But I know your teachers also told you if you have a right angle, you should always look and see if you can use a specific congruence theorem. And that congruence theorem is your HL. We have a leg that is congruent, and we have a right angle. And we are given that the hypotenuses are also congruent. So it is HL congruence theorem. And then we know our last one has to be Cpctc. And we circle our thing right there and bring it down to TS is congruent to VR. Alrighty, y'all. Y'all have a good one.